All right, so last day on logs, we'll finish up just by using, as I said, the formulas we already know to solve equations. That's pretty much what every problem will be today, just solve for x. Before we even start, sometimes you try to solve a problem and there is no solution. Does anybody know the symbol that you can draw if you have a problem that has no solution? Try to solve something and it's a special symbol. Anybody know what that is? Sometimes it stands for the empty set. That's the name of it, empty set. It's a Norwegian letter. Is that right? No? Never saw that? Yeah, hopefully in 4 years you've seen that somewhere. That symbol means that there is no solution. So if you ever get something that you can't solve or you don't think there's a solution, or if you see that as a multiple choice answer on a problem, this means no solution. All right. So I want to try to solve that one. So we have a limited number of things we know how to do. We can change things from exponential to log form or log to exponential. We can use the three properties we learned yesterday to combine logs, split logs, and move exponents around. And we've got those properties to simplify, those four that we saw at the very beginning. Okay? So there isn't really a lot in terms of things we can do. So if I look at this problem, does anybody see one of the rules I just mentioned that I could use here? I see. Yeah. Okay, so we could change things into exponential form. Generally, you're going to want to change to exponential form when you only have the word log once. Okay, so if I gave you, or you had something a little simpler, more like this you're going to want to change to log form. Something like that, you're going to want to change to exponential, because the word log is only there once. Okay, I'm not saying you can't do it, it's just not quite going to help us as much. How about on that left-hand side? Does anybody see something we can do here that we learned? Yep. No, they're on different sides. So the only time you could cancel something out is if you have the same thing on the left and on the right. Like if you had, since you've got the same thing on the left and on the right, you can just cross it out. But these are different log 5s. One's an x, one's a 9.
Could we change the 2 to log base 5 x to the second?
Yeah. You could take the 2, we could put it back as an exponent. And now we have log base 5 of x squared equals log base 5 of 9. So comparing what's on the left and on the right, is there anything there that appears on both the left and the right already, that it already matches? Log base 5. Okay. So this part already matches this part. Okay, so that's the same. The only thing we have to make is this argument match that argument. Okay, so somehow we have to pick a value for x that's going to come out and make this side 9. So this is basically what you have to figure out. So what would x be? 3. Yeah, x is 3. And if I fill it in, I can check it. 3 squared is 9. And on the left, I get log base 5 of 9. And on the right, I have log base 5 of 9. So I've now made the left and right-hand sides match. And that's it. Okay, so that one, all you really had to do is use that third rule we learned yesterday. Move that number in front back as an exponent. And the bases already matched. If the bases didn't match, this would be a lot harder. Okay? But they did match. So. Any questions on that one? All right. Let's try this one. So we have log base 4 of x plus 3 plus log base 4 of 2 minus x equals 1. Okay, any thoughts on this one? Think of the different things we've learned and if any of them apply here. About Marquise. Any thoughts?
You can combine them.
What do you want to combine? The two what?
The argument.
Yeah, we're going to combine these two logs. Okay? Anytime you have two logs on the same side of an equal sign and they have the same base, why don't you combine them together as one log? Okay, that's going to be a little simpler. And Marquise, when I combine them, what's going to be the base?
4.
It's going to stay 4. And how do you combine arguments when there's an addition sign?
You multiply them.
You multiply them. So you have x plus 3 times 2 minus x. Okay, and the equals 1 stays right where it is. Okay, any questions on that step? Okay, now we've got to do a little bit of algebra. Sam, how do I multiply these two things together? Yeah, I have to distribute, okay, just like that. Okay, so let's do that out and see what we got. So I'm going to get, you know what, I'm going to do it off to the side so then I can put the final answer right here. I get x times 2. Jake, what's x times negative x? Negative x squared. Skylar, 3 times 2?
6.
And lastly, 3 times negative x is negative 3x. Question? Yeah, that all looks right. Okay, now we can combine our like terms. Jared, what's 2x take away 3x? Yep, I got negative x. And as I combine them, I'm going to write it in descending order. So that means you usually put the highest exponent first. So the x squared, then the x, and then lastly plus 6. Okay, so now I've got a problem where I don't have 2 logs anymore. Now I only have 1 log. And Sam mentioned something earlier, and I gave you a hint at what you might want to do in a problem where there's only 1 log like this. What could we do with this equation now? Yeah, change it to exponential. Okay. You can't combine logs. There's nothing to combine. There's no numbers in front to move back as exponents. This doesn't fit any of the simplify patterns we saw. So the only thing I can do is change it to exponential. Connor, can you tell me what that would be?
Would you just
Not sure. Anybody help Connor out? How do we change from log form to exponential form? Even though this argument is a little more complicated, it's still just the argument. So just pretend like this is one big thing. Don't break it up.
Moving 4 to the power of 1, so negative x squared minus x plus 1.
Yeah. 4 is your base. Okay. The logarithm always equals the exponent. So 1 is your exponent. And the argument is the only thing we haven't used. From this step on, it's all algebra. Okay? The rest of these steps are not steps that you've learned in here. It's all algebra 1. Okay? So any questions up to this step? How we got rid of, combined the logs and then got rid of it? That's the stuff I taught you. All right, so now let's solve this equation. Okay, what kind of equation is this? Well, usually exponential equations, it's when we have a letter up here.
So then it would be what do you mean quadratic?
This is a quadratic equation, right? So quadratic equations, we either factor them or we can complete the square, which we won't do. We'll use the quadratic formula instead, if we need to. All right, so first thing I'm going to do is 4 to the first power. Okay, and the next thing, when you solve a quadratic equation, you don't usually get it equal to 4. What do you have by itself on one side of a quadratic? 0. So what I'm going to do is move everything to the left. You might say, well, why don't you just take the 4 and put it on the right? That's less work. The problem is I don't like that negative. Okay, if I'm going to factor, I definitely don't want this x squared to be a negative. I want it positive. So to do that, I'm going to shift everything to the left. So I'm going to add the x squared. I'm going to add the x. And I'm going to subtract the 6. Okay, what's 4 minus 6? -2. And now, since I added the x squared, I added the x, I subtracted the 6, what's left on the right? 0. Okay. So now I've got a quadratic equal to 0. And let's try to factor it. Because if you can factor it, it's always quicker than the quadratic formula. What's going to be my first two terms in the parentheses? Yep, x and x. Perfect. Because x times x is x squared. I need two numbers that multiply to give me 2 and subtract to give me 1. 2 and 1. And now we got to be careful with the signs. Some people do the signs first and then the numbers, but it doesn't matter. So is it going to be a plus and a plus and a minus, or a minus and a minus? Oh, what does it say? A plus and a minus? In that order?
No, not that one.
Yeah. So yeah, it'll be a minus and a plus. That's going to give me plus 2, take away 1. 2 take away 1 gives me a 1. Okay, so now I've got something times something equals 0. What's the only way you can multiply two things together and get 0? One of them has to be 0. So either there's a number that makes this 0, or there's a number that makes this 0. But one of these, or both of them, have to be 0. What would make the first factor 0? X equals 1. And what about your second factor? -2. So now the only thing we have to be careful with a log is we never take the log of a negative number. Because if you take the log of a negative number, what kind of answer do you get? You get imaginary. Okay, so I'm going to go back up and I'm going to check 1 and see if I would ever take the log of a negative. Okay. What's 1 plus 3? 4. Is that negative? No. What's 2 minus 1? 1. Is that negative? No. So we wouldn't have a problem using this one. Let's try -2. What's -2 plus 3? 1. Is that negative? No. So it works fine. What's 2 minus -2? 4. Is that negative? Nope. So that one works too. Okay. At this point, one of three things can happen. This is one. Both answers work. What do you think something else that could happen is? One of them works and one doesn't. Yeah. So we get one works, one doesn't. And then the third case would be they both don't work. Okay. And the way you check is you go back up, plug them in. If this ever comes out to a negative, you can't use that answer. Okay. So for example, if I got 5. 5 would work for x here. 5 plus 3 is 8. 2 minus 5 is -3. I'd cross that answer out because it wouldn't work. All right, so this is the kind of problem where if both answers didn't work, you would write that symbol. That symbol means no solution or empty set. If it's a short answer, you could just write no solution. But if it's multiple choice, you would see this symbol. Okay? Any questions on that one? Right, so in terms of difficulty, that's probably the second hardest one we'll look at today. Right? So not really a lot of logarithms or trig steps here. Most of it is just algebra. Okay, this one a lot easier than the last one. A lot faster. Okay, by looking at that one, does anybody see what I can do here? Yep. Yeah, just change it to exponential. You don't have multiple logs to combine. You don't have numbers in front to move back as exponents. There's not a lot you can do. So could you tell me, Katrina, what I get when I change to exponential?
3 to the power of 9 x.
And just by doing that, you already have x by itself, so you're done. Okay, 3 to the power of 9, it's not a huge number, but it's big enough that we would probably just leave the answer 3 to the power of 9. Okay, if you did it out, it's 19,683. So not too huge, but I'd probably just let you leave it like this on the test. Any questions on that one? So here's one I think I started off the week with. Okay, I said, here's a problem. And I gave you a few kind of easier ones to start. And I gave you ones where this number was a power of this number, and you could do it in your head. Well, now 5 isn't a power of 2. So we can't just guess the answer. But we can still figure out what it should be between. Okay? What two numbers does x have to be between? 2 and 3. 2 to the second power is 4. That's too small. 2 to the third power is 8. That's too big. So the answer is between 2 and 3. 2 point something. But now I want to figure out exactly what it is. Any thoughts what I can do with this one? Yeah.
Just use your calculator.
All right, how would I type that in?
With log base A with an ampersand. If you change it to log and then
Okay, let's change it to log first, and then we'll use our calculator. Can you go ahead and tell me how to change it to log?
be log base 2 5 equals x.
Log base 2, 5 equals x. Exactly. And now we just use our calculator. How would you type that in using the formula we learned yesterday?
You do log 2, log 2 over log 5.
Log 2 divided by log 5. Everyone agree with that?
Just log 5 over log.
Yeah. It's always the higher one divided by the lower one. Think of it that way. So log 5 over log 2. Okay, and now just type that in and see what you get. Log 5. Do I need to close my parenthesis? Yep. And then divide by log 2. Do I need to close it here? It doesn't really matter because there's nothing else coming after it. So, and we said the answer should be about between 2 and 3, and we did. Okay, it's 2.32. So this is one you can easily check your answer. Take 2 and raise it to the 2.32 power and see if you get about 5. It's not going to be exact because we rounded it off, but that's what it is. 2 to the 2.32 power. Okay, so very easy to solve this kind of problem if you use a logarithm. And it's not that many steps. Any questions on this one? All right. It's really the same type of thing. John, could you tell me how I would rewrite this one?
Log base x, or base 24. No,
No.
x equals,
Yeah, so it's logarithm always equals the exponent. So the base is the easy number, because whatever the base is in the original problem, that's the base on your log. So what's the base in the original problem? 3. And now if you figure out where those two things go, what's the only number you haven't used? The 24. Okay, so now you're going to type that in exactly the same way that Kyle told us to do the last one. Log 24 on top. Log 3 on the bottom. Don't try to simplify and say 24 divided by 3 is 8. You can't do anything like that at all. Okay? Just type it in. Alright, so we've got log of 24. Hey, so it's about 1.53. Oh, did I type the wrong thing? Thank you. Why did I? Oh, because I said 8. Okay, so 2.89. Any questions on that one? All right, this one's similar, but what would you have to do first here? And if you did this one step, then it would make this problem look pretty much like this problem. So we can't multiply these because we have this exponent here. So that 3 to the x, we can't touch that. John?
Divide the 5 by 8.
Yeah, divide both sides by 8. That's going to cancel that. And now you have a number to a power equals a number. Just like this one. Number to a power equals a number. Any questions on how you'd finish this one off from here? No? Okay, so I'll leave that one for you. This one. All right, so it says 5 to the x minus 2 equals 3 to the 3x plus 2. Okay, and the real problem here is that the bases are different. Okay, if the bases were the same, like let's say I had 5 to the x plus 3 equals 5 to the 2x minus 1. That's easy to solve because these already match. Just find a number that you can plug in for x here and a number you can plug in here that would cause those two to be the same. So basically you just solve this equation. And if you can solve that, get the answer, that's the answer. Okay, but I can't just take the exponents and set them equal here because even if I get the exponents equal, the bases are still different. So that's a problem. So any questions on why I can't just set these exponents equal and do it just like this one? All right, so there's a rule. I can do something with these exponents. What are you allowed to do with exponents? The rule we learned yesterday. Yep? Yep? If there's a log in the problem, you can put it in front. Is there a log in this problem? Okay, no. So why don't we put a log in the problem? Okay? But we can't just put it on one side because it's an equal sign. If we put it on one side, we also have to put it, we got to put it on the other. So the first step I'm going to do is I'm going to take the log of both sides. And I'm going to write what I actually said. Okay, so we've never done that before, but we've done that idea before. Anytime you solve an equation, you do something on both sides. That's all I did. Took the log of both sides. Now I can take these exponents and put them in front. So we've got x minus 2 times the log of 5 equals 3x plus 2 times the log of 3. Okay, now I want to stop for a second and show you what this equation is very similar to. Okay. Log of 5 is just a number. Okay, I'm going to make up a number. Don't write this part down because this isn't exactly the number, but I'm just showing you what it's similar to. Let's say log of 5 came out to 3. Okay, so it's just like you have a number in front of the x minus 2. And let's say the log of 3 comes out to 7. Okay, so all that you really have here is a number in front of each set of parentheses. If you can solve this, you can solve this. They're exactly the same setup. So what would be the first thing you would do with these two numbers, with the stuff that's in parentheses? You would distribute it. Distribute it, and I'm going to do the same thing here. I'm going to distribute it. The only thing that's going to look a little messy is I'm going to write the word log over and over, because I'm not going to do this out. I'm going to save doing that out for till the very last step. So we have whatever the log of 5 is times x, and whatever the log of 5 is times 2. Again, it wouldn't look as messy if I just did out the log of 5, but I don't want to round it off yet. That's why I'm not finding what the log of 5 is. If you really want to know what it is, it's about 0.7. So it's just like having x times 0.7 minus 2 times 0.7 right there. Right, and now we'll distribute out log 3 to the second set. So 3x log 3 plus 2 log 3. Now I'm going to underline a couple of things. I want to see if you notice a pattern in what I underlined. What do the blue things have in common that I underlined, and what do the green things have in common?
The blue have x's and the green just numbers.
Yeah, the green things are just numbers. So generally, when we solve an equation, we like to have everything that's just a number on one side, and we like to have everything that has a variable in it on the other side. So let's do that. Let's move everything with an x. We'll put it on the left. Let's move everything that doesn't have an x over to the right. Now, how would you move negative 2 log 5 to the other side? You would add it. And I'll do it here. And now, how would you move 3x log 3 to the left? Subtract it. Okay, I can get rid of those colored lines now because I don't want you to think they're division. It's a little harder to get rid of them than I thought. Goodbye. Hey. Stay over there. All right, so now we've done everything. That's going to cancel. That's going to cancel. And let's write what we have. There's not really much we can simplify, but we can at least write it x log 5 minus 3x log 3. That's what's on the left. On the right, I have 2 log 3 plus 2 log 5. Now, some people might look at this and say, oh, I have logs with the same base. I could take these numbers and put them back as exponents and combine them, and you could, but it's not going to help you to do that. Okay? Our goal is to get x by itself. I don't really care if you simplify this and make it look nice, because when we're done, I'm just going to look for a decimal for the answer. So combining all this together doesn't really help you at all. So I'm just going to leave it. I'm going to look at the left-hand side. What do both logs have in common in front of them on the left side? They both have an x. And when two things have something in common, you can factor it out. This isn't the kind of factoring where we did in a couple problems ago. This is easier. We're just literally going to take the x out of each one of those. What are you left with if you take the x out of the first term? Just log 5. What if you take the x out of the second term? So what am I not covering? Yep, -3 log 3. So now, and I'm going to keep the right-hand side the same. Okay, now what I basically have is something like this. I've got a letter times a number. Okay, don't write this number down. I'm just going to make this number up. A letter times a number equals, what's all of this? It's just a what? It's just a number. It's a decimal. I don't know what it is, but it's just a number. So just pick a number. This equation is exactly the same as this one. Letter times number equals number. So what would be your last step to get the letter by itself? Yeah, you divide each side by whatever's next to the letter. Okay, so do the same thing here. And that's our answer. Okay. What's next to the letter looks kind of complicated because I didn't do out the word log. But now in the last step, I'm going to type it in and I'll do it out. N divide by log 5 minus 3 log 3. So the important thing to see is it's not anything more complicated than an Algebra 1 problem. You have the word log written everywhere, and I think that's what people look at and they're just like, looks too much. If you take the word log out of it, there's nothing there that's not Algebra 1. Now we should type all this in and just see what we get. I generally don't like to type the whole thing in at once because I usually make a mistake trying to type that much in. But what I'll do is I'll do the top first, and then I'll do the bottom. So we've got 2 log 3 minus 2 log 5. Okay, so the top is -0.444. Okay, let's round it to that. Okay, and the bottom is log 5 minus 3 log 3. Okay, that's about -0.732. What can I cancel out in that fraction? Yep. Negative divided by negative is positive. And now just divide those two numbers. 0.444 divided by 0.732. So the answer is about 0.661. We'll just round it to 2 places. About 0.61. Okay, if you don't like having the word log in the problem, I guess way back here you could do it out. But I would want you to do it out to at least 4 decimal places. Because you're going to use it so many more times. If you don't, your answer is not going to be accurate. And honestly, I think it's a pain to have to write down a number that's 4 decimal places. I think that's easier for me to write and remember. Okay, that's why I don't do it out till the very end. All right, so that's the hard one. It's the hardest one we do. Okay, any questions on any of the steps I did there? All right, so that one takes a little practice to get good at. Let's look at this one. What is something you you might want to do here, but you can't.
Combine.
Yeah, why can't we just combine them? I thought I said anytime you have two logs with addition, you just multiply the arguments.
Yeah, different bases.
They have different bases. Okay, so in this problem, what I'm just trying to draw attention to is you cannot combine. The bases are different. So if I can't combine it, what's the only thing we can do with something like this? If you wanted to type it into your calculator, how can you rewrite that using the formula we learned at the end of class? Like, let's say x was a number. Like if I wanted you to find log base 3 of 5, how do you make it so you can type that in on the calculator?
You take the log of x,
Mhm.
divide it by the log of 3.
Yeah. Take the log of x and divide by the log of 3. Now you just created something with the same base. Base 10, base 10. Could you tell me how you do that one?
Take the log of x and divide it by the log of 4.
Yeah. Now you just created something else with base 10, base 10. Now every log in this problem has the same base. Yeah, that's a good thing. And then from here, I want to take a look at something like this. Let's pretend the word log wasn't there. Okay? All you have is x over 3 plus x over 4 equals 4. What makes this kind of a pain? What's in this equation that's hard to work with? Fractions. Okay, we've got fractions here. Well, we could get rid of those fractions if you multiplied everything by a certain number. So in this case, anybody see a number that you could that goes into 3? 3 and 4 go into evenly. 12. Watch what happens if you multiply everything by 12. What's 12 divided by 3? 4x plus what's 12 divided by 4? 3. So I have 4x plus 3x equals what's 4 times 12? So now I just turned this problem into that problem, and that's pretty straightforward to solve. Okay? So you just multiplied by something to get rid of our denominators. How do you get 12 from a 3 and a 4? You multiply them. So the trick in this one would be take this number, and multiply by them in all 3 spots. Okay? So I'll just write it here. Say I multiplied this by log 3 times log 4. I can't do that. I can't combine them. Like I could do 3 times 4 and say, oh, that's 12. Well, there's nothing I can do here. So multiply that by log 3 log 4. Multiply that by log 3 log 4. And multiply that by log 3 log 4. Now, every time I did that, something canceled. Okay, as 3 went into 12, 4 went into 12. What cancels out here? So I would be left with log 4 log x. What would cancel in the second one? Log 4. So I would be left with log 3 log x. And now on the other side, nothing cancels. You're just left with 4 log 3 log 4. And that's not a hard equation to really solve. It looks hard because it has all the logs, okay? And I'm going to stop pretty much at that step. But let me change all the logs to numbers, okay? Let's get rid of the word log. The log of 4, okay, just is like about 0.60. The log of 3 is about 0.48. And this whole other side is just one number. It's log 3, which I just did, log 4, which I just did, times a 4. So it's 0.6 times 0.48 times 4. And it's about roughly 1.152. So just by taking the word log out from here, here, and here, I think now it looks a lot simpler. Okay, as I said though, I'm going to stop with this step. Okay, the important thing I just want you to notice is that you can't combine them with different bases. You've got to solve it a little differently. It's not too much harder, but it's not as simple as combining them together. Okay, and if you wanted to finish it, you have a log x, you would factor it out and then divide, but that's a good place to stop. So if you understand how I got to this step, that's fine. Any questions on that? Just the first two steps. That's all I want you to understand. Okay. And the last one. Okay, that's a pretty hard problem to solve algebraically. Okay, in fact, you can prove that you can't use algebra to get x by itself. You can't do it. If you just gave me this, then it wouldn't be a problem. I could definitely do that. If you just gave me that, I'll just get rid of the x. If you just gave me that, I could do it. But the problem is there's an x in two different spots. That's what makes this problem really, really hard to solve. So the point here is that I want you to see not every problem with logarithms or natural base e, not every problem you can really solve easily by hand. This would be a good problem to do as a graph, okay, on a calculator. Okay, let me show you how you do that on a calculator. A regular one without, no, maybe there's going to be a bonus question, but probably not a regular question. No. Okay. I'm going to type this in right here. X plus e to the x. I'm going to type 2 in down below it. So I'm going to graph what's on one side in blue. I'm going to have a different graph in red. I'm going to have two graphs on the screen at the same time, a blue one and a red one. And I want to know where the two graphs are equal. What does that mean? If you draw two different pictures, and you want to know where this picture in blue equals this picture in red, all that means is where the graphs intersect. So very easily, the calculator can tell me exactly where they cross, and I don't really have to do any work at all. Okay, that's the one in blue. That's the one in red. Slowly. And it's kind of hard for me to estimate it, but I don't even have to, because the calculator can automatically tell me, by pressing what I just did, where they intersect. And that's the answer to that problem. It's about 0.44. All right, so some problems we wouldn't even try to tackle it with algebra. We just use a graph instead. We're not, in this class, we don't really get into graphing a lot and solving it, but graphing is definitely another way to solve problems, and a lot of times it's a lot faster than using algebra. Every problem we did today, every problem, I could do with a graph, if I wanted. But it's not really something we focus on in this class. Right, so any questions on that one? Okay, so as far as like examples I would really pay attention to for the test tomorrow, examples 1 through 6 are really, really important ones. Okay, 7 is a good example, but that'd be more of like a bonus type question. 8 is not really a question. I just want you to see that you can't combine things with different bases. And 9 would be a good bonus question. So 1 through 6 if you want to focus on certain problems. All right, so homework for tonight, it's on 490. It's not that many problems. It's 1 to 3, 5, 6, 9, and 17 to 21, just the odds. So it's nine questions. Okay, we'll look at that tomorrow. We'll have our test. I will be after school today if anybody needs to come by for extra help. And don't forget, this is our last test for the course.